Welcome to week 2 of Math 210. This is the example x cubed minus y plus 8 in parentheses equals -9. So we're going to walk through each of the components and explain them, and then I'll show you some technology tools that will help out and make the problem a little bit maybe at least more explorable, or at least to give you an opportunity to kind of play with some challenges there. Okay, so for part A, in this problem, it wants you to solve for x as a function of y, and then solve y as a function of x. So in this case, y would be the independent variable and x would be the dependent variable. And in this case, x would be the independent variable and y would be the dependent variable. So for solving for this, I'm going to need to move this quantity over, and then I'll need to take a cube root to isolate x. So x cubed is equal to, so I'm going to add this to both sides. So I get -9 plus y plus 8. Dropping the parentheses here, I have a +8 and a -9. So that's going to give me a -1 plus y. And then to get x by itself, I would take the cube root of x. And that's going to give me a -1 plus y to the 1/3 power. So the cube root is the same thing as a fractional power of 1/3. So I can also put this as the cube root of 1 plus -1 plus y. Okay, so that would be x as a function of y. And now if I want to solve y as a function of x, so I'm going to do essentially the same thing. So I'm going to take over from this component here. So I have x cubed equals -9 plus y plus 8. So I'm doing the same thing, except for now I'm going to move this quantities over here. So we already saw that -9 plus 8 is a -1. I'm going to add that over, so I get x cubed minus 1 is equal to y. And since y has a coefficient of 1 and no power is acting on it, y is isolated at this point. And so I get y cubed minus 1 is this function is my f of x here. And here, this is my f of y. Okay, all right, so that's part A. Part B is to state the domain and range of both of these. Of each case, yeah. So kind of going in reverse order here, the domain of y cubed minus 1, well, the parent function here is y cubed, and y cubed looks like this. Okay? And so the parent function being shifted down 1 is only going to just kind of move this whole graph down 1. So the domain is actually all of R, and the range is actually the same thing. So the domain and range for an odd cubic or an odd polynomial is pretty straightforward. Usually it's going to be both all of the real numbers. Okay, and so now if we look at the inverse function, this cube root of y minus 1, so kind of considering that, it may surprise you, but the graph of this is actually going to be the same thing. It's the same function, and that doesn't change the value. What does switch is the domain and range here actually flip-flop. The domain and range flip-flop here, and so the domain of a function of y is going to be r, and the range is going to also be r. So in this case, it's a moot point because they're the same. Function, its representation is the same. All right, let's move on to part C. C asks us to determine if an equation is a function of either variable and determine if your equation has an inverse. Determine if your equation is a function. Oh yeah, so this is our graph, and so it passes the vertical line test. So it is a function. So it is a function, and it also, we see it, we think about drawing a bunch of passes the horizontal line test. So it's 1-to-1, which means that it has an inverse. So F inverse exists. So we don't have to do any modifications to the domain in order to make the inverse here exist. Just a little side note, let's say you have something like x squared. Well, that graph looks like this. And so here it doesn't pass horizontal line test. So it's a function, but it doesn't have an inverse. So what you do in that case is you create two cases, right? So you have this case, and then you have this case. And so this is the positive square root, and then this is the negative square root. And so in this case, then we piecewise, where we put it together, and then this is the F inverse. This is the F inverse for x squared. So you have, and that's why you get the double squaring, or the two plus or minuses with the root. And so it's because in order to have that inverse function, you have to account for both possibilities. You have to break it up, otherwise it doesn't have a one-to-oneness. That one-to-oneness doesn't exist in that case. In other words, you have two y values corresponding to two different, or the same y value corresponding to two x values. So we need that to be 1-to-1 in order for the inverse to be unique. Okay. All right. So that's just a little note on that one. And then D, if your equation, I guess I should say if your equation is a function, sketch a graph of its parent function. Well, we did that earlier. The parent function for r is y equals x cubed minus 1 is just x cubed. That's the parent function. And so its graph is like this. And it's really helpful to have the parent functions in mind, because then you can kind of get a sense of the shape, and then things like understanding the domain, the range, and those sorts of things become much more accessible to you without having to plot it every time. All right, and then let's see. We're going to do part E. And then these have a bunch of situations. So f of x plus c, what does that do? Well, if this is f of x, then if this is f of x, then adding a plus c to it, is this going to shift it up or down depending on the sign of c? So that this is just adding something. So you get some value out, let's say like 12, and you're adding some number to it. So it's going to shift it up. That's what that is there for. That parameter c adds as a shift up. Let's look at the next one. So f of x minus c, well, then that's going to shift the parent function down by some amount. Okay, so it really is just how's it moving the function, right? So anything acting on the outside of the functions is going to shift it up or down if you're adding it. And if you're multiplying it, then it would tend to shrink it or widen it depending on what you're multiplying by. Okay, so let's look at let's see, part C of part E here. So f of x plus c. And so here you got to kind of figure out, well, that's going to be x plus c cubed minus 1. So what is that doing? Well, it's shifting our x here a direction, either left or right. So we have to figure out, okay, so how is it shifting it? Well, if we look at, let's say 0 here, in order to get this back to 0 with a plus c, it can't be a plus c. It's not shifting it to the right, because if I went to the right, like to c, a value of c here, then I'd add c to that. So that would put me at 2c. So that can't be the case. It actually has to be a shift in the other direction. So it's supposed to be a negative c, because then if I plug in negative c for x, negative c plus c would get me back to 0. So when I've added something to the argument of that function, it actually shifts it to the left. Okay, so this is a shift left, c units. Okay, which means that if it's a f of x minus c, then this would be a shift to the right. Um, units. Okay. And then if we look at part E of E, this is the one that says c times f of x. So what is that doing? Well, it's taking whatever the output of f of x is and multiplying it by a c. So it's going to scale. So if the function was like this, then multiplying it by c will make it narrower because you're multiplying that in value and it's going to make it a higher y value. If c is greater than 1, and it will do something like this if c is less than 1, but greater than 0. Okay, so greater than 0. So if it's in between 0 and 1, it's going to kind of flatten it out. And then if it's a negative, actually, what it's going to do is reflect it. So if c is less than 0, it's going to do something like this, depending on what the value of it is. But this, knowing that c is less than 0, it's going to shift it, and then it'll also dilate it. You either make it really more narrow or widen it out, depending on if the absolute value of the c is less than or equal to 1 or greater than 1. Okay, and then last but not least is f of so f of c times x. This is the last one. This is f. So what does this one do? Well, when you multiply the number x by c, so what you're thinking about doing is, if you think about, okay, so here's my kind of like my parent function, right? So if I look at a number, let's say 1, that's a little bit 0 when you multiply, it doesn't change, it's still 0. But say this is 1, okay, now when I multiply that 1 times c, okay, whatever c is, that means I'm out here at c units. And so that's going to exacerbate or make, so my y value is up here. So what that does is it moves this curve over, and so you can see it will greatly increase the height of the function. It'll have the tendency of like making the function more narrow if c is a big number or c is greater than 1, and it'll tend to really widen it out if c is a small number, so between 0 and 1. And if c is negative, then it's going to kind of have the same situation over here. It's going to reflect the value. Um, and it's kind of interesting. I was just thinking about that. It's kind of interesting. It's going to have the kind of the same effect as this one, right? When you multiply by a negative c, and that's because the this function happens to be odd. So when you input a negative value, that negative comes out, and you get that times the regular function. So both of these are going to have that same effect of um, making it symmetric about the y-axis. So that negative thing is going to flip it over here if c is less than 0. Okay. All right. I hope that was helpful. So that's going through it by hand. Let's look at how technology can affect this. I'm going to jump over to some tech and let you give you the opportunity to see what you'll be playing with in a moment. Right. So if you type in geogebra.org and come here, you want to click on the Start Calculator. And then it's going to open up the graphing calculator that looks like this. The great thing about GeoGebra is that you can use it. You can use it in a variety of situations, and it can be used on your phone or any web-enabled device as well. And you can actually download the app on your iPad or your phone or anyways. Okay, so let's look at these different scenarios, and this is really meant to focus in on the cases that are kind of like the A through E, and that last section is an F, E that we're looking at there. So I'm going to define my function here. So I have x cubed minus 1, and when I hit enter, that's going to create the f of x for me. And so now I'm going to create a situation here, and I'm going to see how each one of those. So I'm going to create the slider C here by hitting C equals a number, and then you can see right here that creates a slider, and it's going to go between -5 and 5, and that should be enough to kind of get a sense of how the functions are changing. So let's go ahead and throw in each of these cases. So we have f of x plus c, plus c. So that's part A. And then we had f of x minus c. And then you'll notice here, if I just went to the negative values, that would be the same thing as doing this one. So I'm going to make sure that I stay within the positive c here, just because I'm incorporating that. So I'm going to say from 0 to like, let's say 9. And that way I'll have explicitly. So you can kind of see already how it's affecting with the different cases here. And then I have f of x plus c. So now I have c inside, and I have f of x minus c. And then I have, let's see, c times f of x. And then, of course, I have f of c times x. Okay. All right, so some of these aren't going to change. And I know there's a lot of different colors and stuff like that. So I'm going to shut off each of these and then explore how it changes when I move c around. So the green one is my parent function. Make that a little bit bigger so you can see a little bit. Here's my parent function. Sorry, I said parent function. That's not my parent function. That's my that's the function that's moving. And here is the original f of x. So I think that's helpful to have kind of there as a baseline to see how it changes. Okay, so now as I move c up, notice what's happening. It may be a little bit hard to see. Obviously, it's moving it's moving up this way, right? And so it may look like the function is actually changing, but in reality, the only thing that's moving is the entire graph is actually shifting up because you're adding that value of c to it. So as c increases, the function itself is not changing shape anyways. It's just moving up the y-axis, okay? So now look at f of c here, and you'll notice that when I do that, because c is negative here, I'm subtracting that value. It's moving down. So it has the exact same apparent value or same result as this. It's just moving it in the opposite direction. Okay, now let's look at f of c here. So here c is at 2.4. And so the bigger I make c, the further to the left it goes. And that's again because that's the value I needed to add the opposite of in order to shift it back to 0. Okay, all right, so let's shut that off and look at this one. And it may be helpful to notice that these are the same distance from the original function. One is just in the negative direction and one's in the positive direction. And it's kind of tricky here because it's opposite the sign. So here we're treating c as a negative, and so as we can become more positive in our c value here, it shifts it further to the right. Okay, and then let's see, how does it change our function here? So we're at a really big c number, so let's bring that back down to something close to 1. Okay, so you'll notice here it's closer to 1, so it's almost identically the same function, right? And again, remember, this is the case when we're multiplying c by the function value. Okay, so let me throw c out here as a slider so I can still keep r here. And so now as I make r bigger, notice what's happening. This one looks like it's moving down, but in reality, what we're doing is we're just shifting the values of what we're multiplying it by. Okay, so it's just becoming narrower and narrower, narrower. There, so that makes it affect the thing. Now you may be wondering, isn't it moving down? And it is because remember, this is c times the function. So that multiple also gets multiplied by that -1 here, which is then moving us down in that regard. But it's not moving us down like in the same way that the plus c minus c was up here. Okay. It's just that multiplication is affecting that -1, so it's moving us down by that amount, whatever the c value is. Okay, and then last but not least here, now that the is insight, so let's see, we can already see the difference. It's significantly scaling. So as c gets bigger and bigger, you're taking that number and then cubing it. Okay, so even 2 cubed is 8 times your original value. So it's jumping it up tremendously. So it's going to have the effect of moving this closer and closer because those are just going to go extremely quick because it's going to grow tremendously faster until c is less than 1. and then you're going to see it's going to start to spread out quite a bit. See if I can make it a little bit. So you can kind of see that as this gets closer and closer to zero, it's dividing by a bigger and bigger number, right? And so so this is spreading it out further and further and further. All right. I think that's all I needed to show you for each of those. So I'm gonna save this, and then I'm gonna allow you to put in your own f of x here and give you access to this so that you can play around, and you don't have to do anything other than change the values of c and then just highlight and turn on, the different graphs here, so that you can see how each of these variables, or how this parameter changes for each of the situations depending on where that parameter is at. Okay. All right. I hope that was helpful, and I look forward to seeing you all in class and seeing how this pans out for you. All right. Have a great day. Talk to you soon.